this video, we'll study general microprocessor architecture based on von Neumann architecture. The design of general microprocessors and microcontrollers is based on von Neumann architecture. It was developed by John von Neumann and others in the year of 1946. It consists of address generator block, program control unit, input-output devices, arithmetic unit, program and data memory. Along with this, it has address bus, and there are few signals generated by the address generator and connected to various devices as shown here. Along with this, it has a data bus which is bidirectional as shown in this diagram. So here we can see that the address generator, as name itself indicates, the function of the address generator is it will generate the address of the memory location. Here we can see that there is a program and data memory. In von Neumann architecture, there is a common memory for program as well as data. The function of the address generator is to generate the address of the memory location where program or data is stored. The processor uses this bus, that is address bus, to access the memory or input-output devices connected to it. The processor sends address of the device for the read and write operation. Hence the address bus is unidirectional. Here we can see that. Along with that, it has a data bus. Here we can see that data bus is a bidirectional. This is bidirectional, this is bidirectional, this is bidirectional, this is bidirectional. It is bidirectional because here we have a program control unit. The function of the program control unit is it fetches or retrieve the instructions which are stored in memory. After fetching the instruction, it will decode the instruction and it will execute the instruction. After executing, the result will be again sent back to memory, and in particular location the result will be saved. So here we are using data bus to retrieve the data from the memory, and again we are using data bus to send the result into the memory. That's why we need bidirectional data bus. Here we have a arithmetic unit. The function of arithmetic unit is it performs arithmetical operations according to the instructions. Here we have a input-output devices. The input may be received from the external device and the result may be displayed on the output devices. As I said, von Neumann processor has single memory to store program as well as data. That is, here we can see that we have a single memory where program as well as data is stored. Single bus to access memory, an arithmetic unit and a program control unit. That already I have explained. The processor executes the instructions serially one after the other. I will explain this shortly. The instruction has two parts. That is, the instructions which are stored in program memory has got two parts. That is, we will call it as machine code. The two parts are, one is known as opcode, another one is known as operand. Opcode is the one which indicates the processor what operation is to be carried out, and the operand is the one on which data the operation is to be carried out. Here I have shown one clock cycle. In von Neumann architecture, in first clock, that is, I'll assume this is the first cycle of the clock signal, the program control unit will fetch the instruction in first cycle. That is, in this cycle it will fetch the instruction from the memory. After fetching the instruction from the memory, the program control unit will decode it and it will perform a particular operation. To perform the operation, we need the data. The data is known as operand. And in second cycle, it will execute the instruction. That is, here I can write execution. Thus, in von Neumann architecture, first cycle it will fetch the instruction. In second cycle, it will execute the instructions. As I said, the instruction consists of two parts. One is known as opcode, another one is known as operand. I will explain with one simple example, that is machine code. So here I will write one simple code, that is move A comma C add B comma C. So here this is the first instruction and this is second instruction. Here MOV, that is move, is nothing but opcode, and A and C are the registers in which data are stored. Those are nothing but operand. Similarly here add is opcode and these two are operand, that is registers in which data is stored. As I said here, the processor execute the instructions serially one after the other. That is, here the instruction first will be executed, then instruction 2 will be executed. Let's see what happens when first instruction is executed. Here the opcode move is nothing but it performs the operation of moving of data from one register to another register. Here we can consider that this is the source register and this is a destination register. Suppose before execution of the instruction, say A is a register, that is content of A is 10, and say content of C, that is register, its content is 20. After execution of this instruction, the content of C will be changes to 10, that is content of A will be copied into C. Therefore, after execution, the content of C will become 10. So in first cycle, fetching takes place. In second cycle, execution takes place. Now in third cycle, add will be fetched by the processor. So in this case, the add function, add instruction will add the content of B with the content of C, and the result will be stored back into C. That is, here content of B will be added with the content of C and the result will be stored back into C. This is how the execution and fetching operations takes place in Neumann architecture. Thank you for watching.